next challenge is entitled Algorithms 1, Introduction to Recursion. And I'm not going to go through and read this entire description to you. It's longer than most. Same with the notes, and I find it's not even that good of a description. But we will talk about recursion. There's a factorial problem to solve, which I believe we've encountered before. But again, we're about repetition here. We crush all the challenges, so let's just get on with it. So, to refresh your memory, recursion is the idea of a method calling itself. So you notice that they've defined a method here called Factorial, and look at it, it makes a call to itself. So you're probably used to seeing, if you have some experience, methods that refer to other methods, they'll refer to outside functions, but in this case it's when the function or method refers to itself. And so, that can sound weird when you're learning and you think of a sort of loop forming, and you're right, you kind of have this problem where you just keep looping and looping and looping. And that's why there are two very important concepts associated with recursion. The idea is that you have a base case where once you hit it, you terminate the recursion. And the second concept is that you're always sort of progressing towards that base case. If you don't make progression toward it, you kind of just sit and spin your wheels and you get into infinite loops. And this isn't weird, right? We use for loops, we use while loops, and if you think of a for loop, we have the conditions, right? At that very last statement, that third one where you increment, typically it's I plus plus, right, or plus plus I, and maybe with the first statement you said int I equals 0, and so you've initialized that counter to 0, and then you're checking if it's less than maybe an array length, let's say some array that's size 10, and then you plus plus I each time. So at each stage you're going 0, 1, 2, and you see how that's progressing toward 10 or whatever target value you have set. It's the same kind of concept here, right? If you didn't do those things in the for loop, you wouldn't progress and you would just loop forever and you'd have the same problem. So it's the same thing going on. In this case, we're going to implement the factorial. They want us to do that. If you don't recall factorial, here's a nice example here. It has the exclamation mark, or some people call it bang. You can see that factorial 4 expands out to 4 times 3 times 2 times 1. You can multiply that out and get 24. You can do the same thing for 5, which would be 5 times 4 times 3 times 2 times 1. And they have them for 3, which is 3 by 2 by 1, which is 6, and 2. You should note that factorial 0 is defined as being equal to 1, and factorial 1 is defined as being equal to 1. Otherwise, yeah, take the argument you've passed in and create this product where you grab the successive integers going down to 1. So let's do that with using recursion. We'll go over to code. Hopefully you've done this in the past, and this would be a good time for you to pause the video and do it again here. Okay, with recursion, we know we're going to call factorial, right? And let's set up that base case we were talking about. What's your base case in the sense of calculating a factorial? It was when you got down to 1, right? That was sort of where it ended. You don't keep going. If you went past 1 and kept decrementing, you'd get 0 and then -1, -2, and once you hit that 0, right, anything times 0 is 0, and it would eliminate your whole product. So you want to stop at 1. So let's check if the input is equal to 1. I'll say less than or equal to 1. This will cover the case that you pass factorial of 0. And we'll say return 1 at that point. Simply return 1. And then in this line we can make our recursive call. And we'll say return num times factorial of num minus 1, right? So imagine we started with factorial of 5. It's not less than or equal to 1, so we would skip that part. We would get down here, and we're returning 5 times factorial of 4, right? 5 minus 1 is 4. So then it calls this again with 4. You're still not less than or equal to 1. Now you have 4 times factorial of 3. So you can imagine it would have done this the first time, right? Then with our second loop, you get 5 times 4 times factorial of 3. For the next loop, it's 5 times 4 times 3 times factorial of 2. Then it goes to 5 by 4 by 3 by 2 by factorial of 1. And then that special thing happens here with 1, right? You finally hit this case where number is less than or equal to 1. 1 satisfies that, and you simply return 1, and you don't even get to this part. You don't make this call. So this factorial of 1 thing gets substituted out. We know it returns 1. Nothing's being deferred here anymore. We know that we have an actual concrete value, 1. And then you can perform this multiplication to return the result. So you could have thought of it like there was a return in front of each of these, you know. So yeah, that's sort of how it goes step by step. And then we can run this to be sure it's correct. Cool, it worked out. So yeah, that's recursion. You're calling yourself. The function is calling itself. You need the base case, and you need to progress toward it each time. We defined our base case as 1. Presumably the input was starting as a positive number. You can enforce that certainly. And at each time we decrement, right? If you have a positive number and you keep decrementing it, you're continually progressing toward that base case. So that was important here to exit out of the loop. So you can think of it sort of like looping, and it's a pretty powerful technique that you will encounter a lot in computer science, and it can be quite useful to you as well. So it's definitely a technique to learn. So I know it's confusing when you first get introduced to it, so hit me up with questions in the comments. Otherwise, we'll see you in the next video. Thanks.